recording this? Very good. So what we learned so far, we start talking about the truth tables, am I right? It's a nice way to write the truth and falsity of our statements in a compact and nice form. Truth tables. Just a quick review for those of you who want to refresh your memory, just a review. Remember that we start by having some simple statements. Simple statements are like P, we had Q, we had R, and if you open different logic books, you might see A, B, and so on as your statements. Well, remember that these are simple statements, just one sentence, true or false. We are interested in combining these statements. This is what we learned so far. We learned how to combine these statements. Using what? Using connectors, using logic operations, using negation. We learned about conjunction. We learned about disjunction. We learned about implication and the biconditional that we discussed before. So negation, not, conjunction, and disjunction, or implication, if, then. These operators, these connectors, help us to form some new statements, combine the simple statements, and make it more interesting. Then we introduced truth tables to help us write the truth and falsity of these new statements in a compact, nice form. We use truth tables to write the truth and falsity of compound statements in a compact and nice form. All right, for example, let's start by having the negation. The negation of statement P, not P. The truth table for this statement is as follows. Remember that here we have one simple statement. We have one simple statement, which is P. Is P. So you're going to have one column associated to P. Let's start. Here I have my P. And the other column is for this new statement, not P. Not P. Well, let us begin. If the truth or falsity of P is just being true, not P is false. This is the very first scenario. A logical statement can be true, its negation must be false. A logical statement might be false, then its negation is going to be true. So this table is called the truth table for negation. That we have to memorize. There is no other way. We need to memorize some basic truth tables. These help us to actually construct the truth table for more complicated, for more complex examples or statements. Now let's talk about conjunction. Suppose you have two statements, P, Q. The conjunction is and, P and Q. All right, very good. P and Q. Now, here you have two simple statements. You get 4 combinations. So here you have 2 simple statements with 4 combinations. 2 to the second power, or 2 times 2, which is 4 combinations. Here you have just one simple statement, and you get 2 to the first, or 2 combinations. And as you can see, you have true, false, just 2 combinations. But here you get 4 combinations because you have 2 simple statements. So what's the table look like? Since we have 2 simple statements, we start by having 2 columns, one for P and the other one is for Q. The last column is for this new statement, which is P and Q. In logic, what we learned is that the very first combination of these 2 statements, true, 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 and true in logic is always true. We memorize this. Okay, what if my first statement is true, second statement is false? If my first statement is true, second statement is false, true and false in logic is always false. Next combination. What if my first statement is false, my second statement is true? What does logic says? When my first statement is false, my second statement is true, logic says false and true is also false. And finally, if both of these statements are false statements, what does logic say about that? When the first statement is false, the second statement also false, false, and false is always false. This is the truth table for conjunction, for and. Another table to memorize. Truth table for and or conjunction. Memorize these. The next one that we're going to discuss is disjunction. Very good. Disjunction. If you have 2 simple statements, P, Q, you can connect these 2 together using disjunction or new statements. The same process. How many simple statements do we have? We have P, Q. We have 2 simple statements. So what's the meaning of that? How many combinations do we get? We get 2 to the second power, or 2 times 2, or 4 combinations, 4 rows, the same as what we did for P and Q. We get 4 combinations. Okay, let us begin. Let's see what logic teaches us about the combination or. Since we have 2 simple statements, we always start by having two columns. One of them is P, the other guy is Q. The new statement is P or Q. So I'm using a different color, P or Q, which is your new statement. Very good. So the very first statement true, the second statement true. If you have this scenario, true or true, true or true, in logic, always true. Next combination, next row. What if the first statement is true? The second statement, however, is false. When the first statement is true, the second statement is false. In logic, true or false is always true. Okay, we learned something new. The second row says, hey, true or false, always true. Remember that true and false is false. But when you switch that operation into or, you get a totally different value. Now logic says, when you have false or true, the outcome value is also true. False or true is always true. Well, okay. It's totally different from and. In and, false and true was false. It's always false. But we changed the operator into or. Now that with a new operator, false or true is true. Now finally, if you have false statement combined with a false statement and the operator is or false, in logic, this guy is always false. This is the truth table for or disjunction. So we already memorized 1, 2, 3 tables. The next one is for implication. We have two simple statements, P, Q. If P, then Q. As usual, you have two simple statements. You get 4 combinations. I'm going to write the table down here for you. Okay, very good. 2 columns at the beginning for P, Q. So I have P, I have Q, and then the new statement, which is P then Q. P then Q. Okay, very good. So let's see what logic tells us about the combination of truth and falsity of these two statements. Logic says, if the first statement is true, the second statement is true, true, then true, always true. Okay, wasn't that difficult? True, then true is always true. What if my first statement is true? My second statement is false. True, then false, always false. Okay, very good. What else logic say about implication? It says, hey, if you have a false assumption, but your conclusion is true, false, then true. This guy always true, everybody. It's always true. And finally, if you have 2 false statements, your hypothesis is false, your conclusion is false, false, then false, always true. This is the truth table for implication. Very good. The next connector is biconditional. P, if and only if Q. I with double if and only if, or biconditional. With one arrow, you have a conditional implication. Double arrow, you have biconditional. The same as before, we have two simple statements to get four combinations. Let us begin. Very good. So we have the very first two columns dedicated to simple statements. Two columns, P, Q. The last column is dedicated to this new statement, P, if and only if, Q. So what logic tells us? It tells us that true, if and only if true, true, if and only if true, must be true all the time. Next combination. If the first statement is true, but the second statement is false, true, if and only if false, must be always false. Next row. Well, what if my first statement is false and my second statement is true? False, if and only if true, must be always false. And finally, if both of them are false, false, if and only if false, always true. False, if and only if false, always true. This guy is the truth table for biconditional. So this is just a review of what we learned so far. Now we're going to make it interesting. We're going to use what we just learned and construct truth tables for new statements.